Today I'm going to be looking at this interesting piece of equipment here that has been sitting outside on top of a tower for somewhere over 10 years, maybe 15. Any guesses yet? Does that give you any more clues? Anyone who recognizes the name Trimble should recognize this as a GPS antenna, a industrial grade GPS antenna specifically. This particular one was used as a master timing reference for a paging system that's been defunct for several years now, and my tower crew just finally got around to pulling them off the tower. There's a whole bunch of them sitting in a box at work, and I don't think there's any use for them. So I'm going to take this one apart and just see what makes it tick inside. So the nameplate doesn't give an awful lot of information. Serial number, model number, the model number 23632-20 if you want to look it up. There's not that much information to be had online. This appears to be 1998 45th week manufacture. Here we have a pipe thread mount, and that's how it was sitting on the tower. It was just mounted like that. And then we have a 12-pin circular connector here, which theoretically is weatherproof. Again, it was sitting underneath the shelter that way, so it would only be the most driving of rain that could even get close to it. So to open this thing, there are no screws. There's just a whole bunch of clips on here, so I think I'm going to need all of my spudgers to hold those open while I get into it. Shouldn't be too difficult, I think, but I just need to go around and sort of hold all those open until I can get a pry on them. We'll see what happens here. Maybe I should just not be so precious with this and just break these tabs out so that I can actually pry into it. I think that makes more sense. So I'll just get a bit violent on this thing and, again, come back. This thing is putting up a serious fight. Obviously, it's not going back together. Fortunately, it doesn't need to. But wow, that is... I think that is actually glued in there. I'm going to keep fighting with it, and I'll come back once I got this radome shroud off here. This is going to take some time. Oh, I think we're getting there. Oh, okay. Is that finally going to come out? There it is. Hey. So it's pretty obvious, based on all this glue in here, that it was never designed to be opened. But with perseverance and the correct tools, and some of the incorrect tools, we're in. So what do we have up here? Apparently their internal code name was Bernie GPS, made in the USA. For those that are interested in such things, we have a little cross-polarized antenna there with a little matching and amplifying tuning kind of board there. Down here we have a Raycon branded 16.368 megahertz resonator, oscillator, tuned circuit of some sort. Interesting. And not much else we can see. That is a nice thick solid board with a ton of vias going through it. There's the connector, and it looks like there's an option for a different connector with fewer pins on it. And that's about it. Oh, there's this little rubber gasket around the edge, which is partially holding it in, but I think The nut on the connector is the other part of what's holding it in. So now I have to undo that connector with the wrong tools. Well, I suppose I could start with the right tool for the job. See if it actually works. Kind of fits in there, but not really. Pliers maybe? Oh, there we are, getting some turn. Okay, well, that part's not going to be quite as hard as I thought. That's nice. Still really tight, so I'm assuming there is some kind of thread lock or adhesive or something on that thing, because why wouldn't there be? Okay, that's that out. Now if I push on it, nothing happens. Oh, there we go. Again, correct application of the right tools. Well, being an RF device, I don't know what I was expecting other than an RF shielding can that is soldered on all the way around for a nice tight seal, just to keep the high gain amplifiers that are inside here from getting interfered with by anything in the environment. The only signal that they will be able to get coming in is coming in through this little antenna and its filtered input here. Just for fun, I'm going to see if I can pull this antenna up and out of the way, or at least up and out of its shape here, so we can get at stuff underneath it, just to see what's there. I don't think I'm going to learn anything from that, but we shall see. So one thing we can learn from this antenna is it's actually a couple of dipoles, center-fed dipoles. There's that side and that side. It's kind of like two sets of rabbit ears for your old TV, only specifically tuned to the GPS frequencies and much more precise. That's all there is to the antenna. These bits on the end are just mechanical anchoring. And then on here, there's one side of the dipole goes down into the circuitry, and there is the other side going down into the circuitry. And again, these are likely filters, and then we got this RF can on this side, which is shielding whatever magic is going on down in there. Not going to learn more until I start removing some of this RF can nonsense, which is going to be a royal pain. So, more destruction. I think that's enough to get this kind of out of the way. I'll just worry those last two solder points off, and there we go. Now we can see what makes this thing tick. It's a clock joke. This thing is a timing source. You know, never mind. So that filter and feed horn and whatever else on the other side attaches here. There are two physical mounting points. That will be the RF can, the shielding. And this is a little piece of circuit board that pokes through, and we've got two sides happening here. One side goes over to this component here, which is again probably maybe a transformer, maybe some kind of filtering. Looks like it's got two sections to it there anyway. Also coming off there, we have these little squiggly tracks, and a capacitor, another squiggly track. Those are probably going to be inductors or time delays on the board. I'm going to guess they're acting as inductors, which would mean inductor, capacitor, inductor, and the one side of the capacitor goes to ground, so that's probably some filtering. Then we go up to here, another capacitor, more capacitors, 470J and 120J, and it disappears into all that filtering network. So the other side of this component, at least the other track that I can see, goes into this Trimble specific chip. So that will be doing probably detecting of the GPS signal, demodulating, maybe something like that. That would be my guess anyway, because that's the only Trimble specific chip on here. Everything else is coming from other more common manufacturers. So up near the connector, we have these two components which look like they should be capacitors. That guy is a diode, which makes sense because there is power coming in from this connector from the whatever is controlling this thing. We got another diode over here, which I slightly mangled in desoldering. So power is going to be coming in there. It's kind of hard to follow the tracks, and I'm guessing that this is a multi-layer board. This side is going to be all ground plane. This side has a huge ground pour on it, which the CAN was connected to, and a bunch of other stuff. So I'm thinking that there are a bunch of internal layers, which are going to make it, like I said, impossible to trace the circuit on here. But that's okay. I wasn't going to reverse engineer it anyway. Let's dive a little deeper and try and identify some of these chips on here. Start with these two power devices, which look like they're Motorola part numbers, an R7N. Based on that diode beside it and some capacitors, I'm going to guess that that's probably power supply related. So I was mistaken about that part number. It's P2F, which was the second line. And if this is correct, then it's a PNP silicon transistor. Complement to the 2222. So this is just a super generic PNP transistor. Okay. So just over from those two transistors, actually connected to them, you know, this little 8-pin chip here, 822 or 11722. What would that be? Is that part of the power supply maybe as well? Apparently it's a dual op amp. If we're still in power supply mode, that could make sense being used as a comparator. Yeah, I can live with that explanation for now. And then there's a couple of really small transistors, too small to read. They're probably just signal transistors of some sort. Capacitors, a couple of fairly beefy little rectifier diodes. That, to me, looks like an inductor, which all makes sense. So this whole chunk up here is power supply world. Let's carry on to the more unusual stuff. Like the brains of the operation, Motorola MC6830. So that will, like I said, be in control of everything. That is going to be a microcontroller, microprocessor chip. This little guy over here, or these two little guys with it, are probably going to be memory for it. We've got the Trimble chip over here doing all the RF goodness. A couple of Mitsubishi chips down here. Let's see if we can figure out what those guys are. M5, M52, 56, etc., etc. Well, yes, that makes sense, being in such close proximity to the main processor. Those two chips are both static RAM. Okay. Figured I'd look up that Motorola processor while I was here, and yeah, it is in fact the Motorola 68000 series processor. I'm not going to go through this entire data sheet, but this is a small computer. This isn't even a microcontroller. This is a processor. And yeah, there's 191 pages of data sheet here, so feel free to look it up if you want some reading, but I'm not going to go too deep on this. It's just a powerful processor, a 32-bit processor from back in the day. Interesting to see in something like this, though. So the only things left on this board that we haven't looked up are this guy here and these two down here. And looking them up is going into dead-end territory. I'm going to guess this is some kind of signal processing going on, but I cannot be certain. So this guy has a few connections that go over to the processor, but it has a bunch of connections that go over to what looks like it should be a ribbon connector or something. So maybe a different version of this board connects to a second board in the same package. I don't know. Also over here, we have an unpopulated chip with some pads going out to that, which of course I don't know what that's going to be either. And one more unpopulated footprint down there, and that is about all we can learn about this board, at least in its current situation here. I'm going to do a bit of Googling, and I'm going to clean up my workbench a little bit and see if I can find any information about this thing other than what we have already learned. Well, does this look familiar? This is interesting. This guy has the actual pinout of that connector there. So it can run on anywhere between 8 and 36 volts DC. Ground is down there. And then it has transmit and receive in RS-422 format. So this is a protocol that can handle up to 1.2 kilometers or 3,900 feet. It uses differential signaling plus and minus 6 volts, which allows it to be very good at rejecting interference and whatnot over those long distances. Similar to RS-485, which we've seen in a few other things, CAN bus and DMX512 both use variants on this. And again, they are designed to run in noisy environments over lengthy chunks of cable. So yeah, seems like a reasonable protocol to use. Unfortunately, this doesn't have any suggestion as to the actual, data packets and that stuff that's happening on it. This is just the physical transport medium, the layer 1, if you will. A bit more hunting around found me this document, which is mostly just a sales document. They say they've made this line of antennas since 1991. Again, the one that we've got here was at 98, I think was the manufacture date on it. So they also say that it runs RS-422 485. So I wonder if I can use one of my Max 485 adapters to talk to it or to listen to it. So here is some more technical specs for it. Operating temperature between minus 40 and plus 85. So they're saying that it can do surveying to within meters. So it's not the millimeter millimeter accurate stuff that they do use for actual surveyors. But that's okay. We weren't using it for that anyway. We were using it as a time base. And this one does generate pulse per second outputs to within 50 nanoseconds of accuracy. So that is exactly what we were using it for in the old paging system. And again, there is the voltages, reverse polarity protected. Yeah, we saw those diodes inside the thing. Oh, it's 9608 odd parity and 1. Interesting. So there's TX and RX A and B, or RX A and RX B, yeah, which corresponds with these ports A and ports B over here, and we can see the pins on that connector. I wonder if I can listen to this thing. So if I'm going to power this thing on, maybe I should try and put it at least a little bit back together. I'm not really expecting to get any kind of a signal out of it. All right, I've just got the power connected for now. I've got 12 volts on here. It says it can run on anything from 9 to 36. So, power on. Seems to be running. It's drawing about 170 milliamps. That's reasonable enough. Okay, so I'm going to guess that it's sort of working right now. Next step, I'll connect up this RS-485 to USB adapter and see if we can get any signs of life out of it. So according to this, one transmit pair transmitting out of this device is pins 4 and 5. The second pair is pins 8 and 10. And the third pair is pins 11 and 12. Since I'm not quite clear on the markings of this connector, I figured out the outside ring of pins from 1 until 9 just by tracing out the power and ground connections. So the ones in between there I've got figured out, but 10, 11, 12 are just 3 pins in the middle, and I don't see any numbering on them. So I think, just by process of laziness, I will start with pins 4 and 5. So now I've got the data connection hooked up to my USB to RS-485 adapter. Verified that the polarity matches what that information says. And I've got my serial port set up for 9600 8 odd 1 like it says. And now if I power this guy on, hey, I got a data. I don't know what that means, but I got one. Presumably that was just what it did during the boot up. I'm going to let this roll for a minute or two and see if it does anything else. So it seems every minute it's giving me another K and I guess a line feed, but not a carriage return. Okay, let's see, I guess, if we can find the other transmit signal, which should be on pins 8 and 10. Okay, let's see if that works. Yeah, no shorts. Okay, good. Power on. No messages. Let's wait for a minute or two. I remember that on that other port, some messages took a little while. This thing calls itself NEMA. I'm not quite sure what format I'm expecting there. Or maybe I'm not expecting anything until I get to satellite lock, which, like I said, it's not going to do because I'm in the basement. I'll give this a couple minutes and see what happens. Okay, well, several minutes has passed and nothing's happened there, so let's try this third pair, the 1 pulse per second on pins 11 and 12. Okay, and there's pin 11 and 12. Let's see what that does. So it looks like that pair isn't going to show me anything interesting either. So 1 pair out of 3. At least we know that the thing is somewhat still working. I didn't destroy it. Well, it was a partially successful experiment. At least we got some information out of it. Now maybe if this thing was actually outside where it had a clear view of the sky, then we might be able to get something out of it. But unfortunately, that's not gonna happen, at least not with this one. I may have to see if I can get my hands on another one that's still intact and see if I can get my hands on the cable that mates with that, or the connector that mates with that, and try and run one outside. If I got enough cable, if I can get enough cable to get outside from here, then maybe we'll try that in the future. Like I said, if I can get another one that's not butchered like this one is. Anyway, that was interesting. It's always fun to take something apart, even if the magic is 90% hidden in the chips. Still kind of cool to see how it's put together. That little antenna was a nifty little thing, I must say, too. Anyway, yeah, that's about all I'm going to do with this thing tonight. Thanks for watching. As always, questions and comments down below in the comment section. I will talk to you later. Oh, right, and the beer, in case anybody was wondering, it's Red Setter Irish Ale, Irish Red Ale from Stone Angel Brewing in Winnipeg.